Hi, everybody. Can you hear me? Great. Okay, super. Welcome, everybody, to our infectious disease office hours echo. It's November 2nd, and we wanted to start right on time since I think there's going to be lots of information. I'm Joanna Katzman. I'm a neurologist. I work at Project Echo and UNM Hospital in the Pain Center. And I want to introduce my colleague, Carla Thornton. Carla, do you want to just say hi real quick?
Sure. Thank you, Joanna. Carla Thornton here. I'm infectious diseases physician. I'm one of the associate directors here at Project Echo. Welcome, everyone.
Thanks, Carla. Wanted to let everyone know to just keep your video on mute if you can, just to eliminate some extra noise, but we love to see your face. So if you have a webcam, a camera, please turn that on so we can see you and you can see us. It's in line with the Echo model. We don't mind at all if you eat. It's lunchtime here in Mountain Time in New Mexico, but many of you are in different time zones, and that's just great. We do have our digital librarian on, and they're going to be copying, putting things in the browser that are evidence-based, evidence-guided materials, and you can just copy what looks good to you and put that into your own browser. At about 45 minutes after the hour, you should be getting a CME link where you can get your no-cost CME. And even if you don't need that, please take the time to fill it out and let us know what you think about us. It really does help. We do look at these thoughtfully and try to make changes based on the program. Well, we have a lot of information, starting with our leader, fearless leader, Nestor Sosa, who's the division head and in charge of infectious diseases at UNM Hospital, and he's going to lead us off with a PowerPoint, followed by Leslie Hayes. Thanks, Nestor.
Thank you, Joanna and Carla. Let me just put this in the big screen thing here. There you go. Okay, so hello everyone. Just before I go into the articles, I just want to remind everybody that the cases are really going up. I mean, we have a lot of new patients in the hospital, so I think we need to continue this seemingly endless fight against COVID-19 and double our efforts to prevent and to mask up and social distance and everything. So let me go through some of the papers. Really today it's most of the papers that I'm going to review are interesting, are somewhat cool. We have the first solid data on one of the monoclonals, the Eli Lilly monoclonal, which is actually the name. It's LY-CoV virus 555. It's not the one that was given to President Trump. It's the other company. But it's interesting that they published their experience, the phase 2, in the New England Journal a couple of days ago. And the title of the paper is SARS-CoV-2 neutralizing antibody CoV 555 in outpatients with COVID. So this was a study in which they provided the antibody by injection, via injection. Is an intravenous infusion in patients with relatively early disease, less than 3 days since they had been tested. And they had mild to moderate COVID. So these were not ICU patients, they were actually outpatients with mild symptoms. And then they follow them. They actually enroll a quite significant number of patients, but 100 received 101 received 700 milligrams, 107 2,800 and 101 7,000. They were testing different doses, and there are more doses, but they didn't publish the results of the other intermediate doses. And then 143 patients were assigned to the placebo arm. The distribution between the patients who received the monoclonal and those for placebo was very similar. Median age 45, 30% were older than 65 in the monoclonal, 20 were in the placebo group. So relatively well balanced, both arms of the study. The main finding, or the primary outcome, was actually regarding viral load. They measured viral load at different points, but the primary outcome was to see if they were able to clear the viral shedding or RNA shedding, because they were measuring really RNA by day 11, and they did find an overall decrease in the percentage of patients who clear the virus in the monoclonal arm, but it was not statistically significant. And in fact, interestingly enough, the intermediate dose was more effective, and you can see -4 as opposed to the 700 3.67 and the 7,000 3.38. So sort of a weird finding that there was no dose effect. It was actually the intermediate dose seemed to be better than the small and the large dose. So it's something that not very clear to me. The other finding, which was not related really to treatment, was sort of they were able, because they did so much intensive viral load measurements, they were able to find a correlation between being hospitalized and having a high viral load, independent of treatment. This is, as I said, not something related to treatment. And this graph illustrates that. You can see in these squares are the CT, the threshold, which is sort of an indirect measure of the viral load, and the viral load was, as you expect, going down as the day moved. But they noticed that those who did not have a decrease in the viral load were hospitalized. So there was a correlation between not being able to lower your viral load, independent of if you receive placebo or the treatment, but having a high viral load correlated with being hospitalized. So that was sort of something unexpected that they didn't anticipate it in the trial, but they published this graph in the paper saying that they observed that. The other finding, which was also not statistically significant, was the percentage of hospitalizations in the different groups. And they found that those who received placebo needed hospitalization in around 6.3% of the cases. And those who received the 3 doses of the monoclonal, the frequency of hospitalization was 1.6. They didn't publish any statistics, so I calculated a chi-square, and there was there's no statistical significance in this group overall, between 6 and 1.6 for the number that they had. Although they did mention that in those patients with more than 65 years of age or a BMI of more than 35, so presumably patient with high risk of complication, the antibody did show a significantly decreased frequency of hospitalization, 15% in those who received placebo versus 4%. And I calculated a P of 0.007 in that group, but that was not a primary objective. So the study was not designed to prove that. What it was interesting that at least in the high risk patients, there was some protection from hospitalization, meaning protection from getting worse. And there was also a slight but overlapping improvement in symptoms. You can see that the blue, which is the pool monoclonal antibody, was kind of lower. So the scale of symptoms was better. The improvement was better with the monoclonal as opposed to the placebo. So, there was sort of a tendency towards rapid or more rapid alleviation of symptoms in those who received the monoclonal, but again, not statistically significant. So this trial sort of, didn't have any red flags, but it really wasn't very dramatic. I mean, most of the differences were not statistically significant, were just numerically different, but not statistically significant. So we have to wait. This is an interim analysis. We need to wait for the larger trial, the whole group with all the doses to really have an analysis, or a phase 3 with not hundreds of patients, with actually thousands of patients, to see if these monoclonals are effective in preventing hospitalization or decreasing the viral load, which were the objective. And I just want to mention that, monoclonal antibodies, as you know, they are derived from convalescent plasma. They need to be produced. They're really expensive. We have experience with monoclonal antibodies in other diseases, in cancer, in rheumatologic diseases. And we know that, a single vial of these monoclonals usually go by, several $1,000s. So, but there's something I think, cooler than the monoclonal antibodies. People are looking for other alternatives, and interestingly enough, alpacas, these mammals that are prevalent in South America, they actually produce sort of a smaller antibody. They don't have all the heavy and light change like a regular antibody, a conventional human antibody. They're actually smaller, and they have been able to prove that you can use this the active part, the part that attaches to the epitope, and use it as a and they call it nanobody. So there are investigators working on developing these nanobodies, which with some chemical modification can be really stable, can be easier to produce because they can be mass produced in animals, or synthesized in viral in bacterial cultures. So it's interesting that we're going to look, and in fact, there's a publication on an alpaca nanobody neutralizes SARS-CoV-2. So they were able to prove, and here the antibodies are in blue. This is the spike protein, in different positions. They rotate 180 and 90 degrees. And the important thing is that these antibodies seem to attach to the active site, the area where the spike protein meets the ACE2 receptor, and neutralizes the effect of the protein. So these tiny or nanobodies can actually work, and if they can be mass produced, they may be a cheaper and easier to produce alternative to the full-blown monoclonal antibodies. And the other thing that people are studying are called mini proteins inhibitors, in which they actually, what they did, and this is again the spike protein, this is the ACE, the receptor, and they look at specifically what part of the ACE protein attaches to the receptor binding domain of the spike protein, and then they actually synthesize this piece of protein from the whole ACE, just a smaller protein, and they prove that they can actually inhibit the union of the spike protein to the ACE by using these so-called mini proteins, which are not antibodies. It's just like a mimics part of the ACE receptor. So I think it's a clever idea. And the other way to do it is simply to take like a library of proteins that these companies usually have, and with computer animation try to test which one attaches better, and then use it in animal models and human models. So I think these are probably going to be the future after monoclonal antibodies, or if monoclonal antibodies are not effective. These are things that may be developed in the near future. But I thought it was nice to see what their researchers are looking for this into the future. The other paper that I want to present, it's about the durability of COVID-19. And if you remember, we presented probably a couple of months ago data on how worried we were because the antibodies that we produce after an infection seems to wane after a few weeks or 2 or 3 months. But there's new information, more robust information, and in fact, they called it the paper "Robust Neutralizing Antibodies to SARS-CoV-2 Infection Persists for Months." This group from New York actually studied almost 20,000 patients during the outbreak in New York, and they measure using ELISA and using neutralization the levels of antibodies. So this is pretty remarkable data, because it's not like the previous studies were like 100 patients, 50 patients. Now we're talking really a large population of patients that had SARS-CoV-2 or COVID-19. And they found that the great majority of patients developed some reaction. Over 95% of the patients had some degree of positive antibodies. And they found also a good correlation between ELISA, so the regular measure of antibodies, and neutralization. There's actually a linear correlation between those two. So you can use the ELISAs and the regular serology test as a surrogate marker for neutralizing antibody, which is good. It's important from the practical standpoint. And they found that a lot of, almost 40% of the group had very high antibodies, like over 3,000, 1 in 3,000. Another sizable percentage, 1/3, had at least 1 in 960. So a significant proportion of patients develop, at least early on, good levels of antibodies, which correlate with neutralizing antibodies, as we said. And then the decay, it's in their opinion, was really minimal. As you can see, this is all the way to day 148. The decay is relatively mild. the overall titers. Obviously, if you have a very high titer, it goes down a little bit, but still, 140 days, the median was around 960. So this is sort of good news, at least for a few months. We are supposed to have neutralizing antibodies and antibodies in general circulating after SARS-CoV-2. And I think this data, it's more credible than small subset of patients that have been studied in the past. And the other paper that I want to talk about, and bear with me, this is sort of more anthropologic paper than medicine, but I thought it was really interesting. And the question is, what is the link between Neanderthals, the Homo sapiens neanderthalis, and COVID-19? And actually, there are two papers that if you remember, we have been discussing, like looking for association between some genetic marker and severe disease. And in fact, they published this on the 15th, I think, of October in the New England Journal. They did genome-wide association, GWAS association. So they look at all the SNPs, all the single nucleotide variations in a group of patients with COVID-19 and controls. And then they found actually two signals, one in chromosome 3 and another one in chromosome 9. The one in chromosome 9 has not been validated, and it's really weak association, and is a relationship with the ABO blood group. But more interestingly, they found a stronger signal around chromosome 3. And actually, another paper in Nature actually proved that this is the main genetic marker for severity of disease, or the most important in genome-wide association. And it affects actually a large section of the DNA. There are approximately 6 genes that may be implicated or related to these variation. But the interesting thing is that this guy, Svante Paavo, it's one of the researchers who have looked into ancient DNA in Neanderthals, in ancient modern humans, and also Denisovans. And he and Hugo Serber published this paper because they found that this specific part of the chromosome, it's approximately 50,000 bases. It's inherited from the Neanderthals. And in this paper, obviously, they go through all the methodology explaining that. But I think the easiest thing to understand is that they put the different types of these 50 haplotypes from people that have been studied in the Human Genome Project, and they found that in pink is the area with the abnormal haplotype, the haplotype that predisposes you to having severe COVID. And they actually found that it was the closest association with a Neanderthal that died 60,000 years ago in Vindija, which is, I think, the south of Croatia. So they found that these modern humans, or actually, COVID patients who had severe COVID and had this variation, were their DNA, that part of the DNA in chromosome 5 was very similar to this person, this Neanderthal person from the Vindija region in Croatia. So what practical repercussion has that is that you can actually look for the Neanderthal genes in the different parts of the world. And in fact, in Bangladesh and some parts of India, a sizable percentage of the population are heterozygous for these predisposing genes. So it's interesting. And in fact, there's a paper, or actually a communication from England, in which they found that people from Bangladeshi background have almost 2 times more risk of having severe COVID. So, sort of to put this together. So in this area, there's a higher penetrance of the genes from Neanderthals, and they do seems to have a more severe clinical course. So we don't know why, this gene, and why the Neanderthals and not the Denisovans, the other, hominids that were, walking around 60 to 100,000 years over Earth. But obviously they mixed with us, they gave us this piece of DNA, and unfortunately, this specific piece of DNA seems to be associated with severe disease. So I thought it was interesting. I took anthropology in my medicine class, and it's the first time in 50 years that I can use the little thing that I learned in anthropology. And finally, just a headline, the CDC published that the multisystem inflammatory syndrome has also been reported in adults. I think they went into describing these cases. I didn't have time to read them in detail, but I will probably will in the next. So at least the unfortunately, the multi-inflammatory syndrome doesn't just only affect kids, but also seems to be affecting older people in a similar fashion. So we have to follow these, and this is a sort of a post-infectious phenomenon. I think that's it. I took a long time. Sorry.
No, Nestor, you're good. We learned so much from your presentation, so thank you so much, Nestor. So for everybody on board here, please chat in your questions you have from Dr. Sosa, and we're going to move right on now to Dr. Hayes is going to be sharing her slides with us. As you know, Leslie is a family medicine and addiction medicine physician in northern New Mexico at El Centro, and she is going to be presenting a little bit of good news. Thanks, Leslie.
I don't know about the rest of you, but every time I have looked at either the New Mexico or national statistics this week, I burst into tears. And I just thought everybody might deserve a little bit of good news, especially with the election. I think we're all stressed. So I went to find good COVID news this week. So first thing, Taiwan and Australia both have had no new cases. Taiwan has actually at this point gone 200 days without a confirmed locally transmitted COVID case, which I just think is amazing. And Australia actually recorded 0 new COVID cases for the first time in 5 months. My daughter was actually living in Melbourne this year, and she was planning to leave Melbourne actually the day they went into lockdown, and they had to frantically rent a car and drive across the border to get to Sydney because of the lockdown. But it clearly worked because Australia has had no new COVID cases for the first time in 5 months. And then I thought this was really pretty nifty. There's 2 New Mexico tech scientists, and they're working on a nasal spray to protect against COVID-19. And apparently it's just going to be a barrier method. And they found that they initially designed it to work against multi-drug resistant bacteria and fungi, and they altered it to protect against COVID-19. When they put it in a Petri dish, it killed 99.977% of COVID viral particles. And they're doing human studies, and they expect it to be both cheap and over the counter. And you would just basically need to spray it in your nose like every hour all day. And if it worked, I thought that would just be a really nice thing to have. And then mortality from COVID-19 is decreasing. So this particular study, they examined discharges and mortality from 5,000 hospitalizations for COVID-19 in 3 New York hospitals. And they adjusted it for demographic factors such as age, sex, and race and ethnicity, admission, vital signs, and any comorbidities. Because what they did find was from March through, I think it was July, they were looking at it, that people admitted tended to be younger and tended to have fewer comorbidities, which I think is actually a good thing because it does seem like hospitalizing people early does make a difference in mortality rate. But what they found is for people who were admitted as sick, same age, same comorbidities, they were less likely to die. And so the blue-green here line is the actual mortality. And then they adjusted it for all of the comorbidities in the age. And what you can see is it has just gone steadily down from March through August. So that is reassuring. Even though none of the treatments we have are great, it does seem like adding them together has really made a difference in the mortality rate. So, and then this made me very happy. Flu vaccine is way up. CVS has already given as many shots to date as it gave during the entire flu season last year. They expect to double the number of flu shots by the end of this year. Walgreens has also administered 60% more. And the CDC has said that manufacturers are producing record numbers of flu shots to meet the demand, and they have distributed many more at this point in the season than last year. So, oops, let me go back. And then just a few other articles of interest. These are not necessarily cheerful and good news, but I thought they were interesting. Peter Hotez is this wonderful vaccine scientist. If anybody's interested in one of the best books on vaccines is his book on vaccines didn't cause Rachel's autism. He has a daughter who's on the autism spectrum, and he talks about vaccine safety. But this particular one was on anti-science extremism in America and how it's sort of being exported around the world. And it was quite interesting. Robin, I don't know how to say her name, Schoenthaler, I think, is a cancer doc in Boston who writes a lot of articles about COVID. This particular one on Medium was really, really good on is it worth it to have Thanksgiving? How can you do it safely? Basically, hold it outside, quarantine for 14 days ahead of time. And I think it's well worth sharing with anyone you know about whether or not you should be having a Thanksgiving dinner this year. And then this article was an editorial from USA Today that I really liked about Trump is wrong to accuse medical professionals of profiting from diagnosing COVID-19. And they were from multiple different specialties. And then this Twitter thread by Dr. Ashish Jha was on why hospitals actually do get paid slightly more if they diagnose COVID-19, but it doesn't mean that there's fraud or incorrect data. And I thought it was really useful. I sort of knew it at some level what he was talking about, but it really explained in great detail exactly why hospitals are getting paid more and why this is actually a good thing and does not give us incentive to overdiagnose or commit fraud. And then this New York Times article was so cool. They basically went down to the molecular level on masks and showed you little viral particles floating through and how the masks actually work to take them out. And it's worth it just for the graphics. And then Rana Adish is intensivist in, I believe, Michigan. And she wrote a wonderful book on her own experience as being critically ill. She wrote an article about taking care of COVID patients and what it's like for the medical professionals called The Shape of the Shore that's in 2020 Intima. And it's well worth reading. And just a reminder to vote. And that's all I have.
Thank you, Dr. Hayes. As usual, just like Dr. Sosa, we're so appreciative of your information. I think I would like to turn now to Dr. Carissa Colbreth, who's the medical director at Tricor Labs. I think Carissa's on and has a couple of things to say.
Hi, good morning. I am on, but I don't have any slides today. So I'm happy to just take questions on testing. There have been some just testing updates here locally in New Mexico and nationally. And so just happy to take any questions related to testing as well as related to testing for other respiratory viruses. So happy to take any questions.
Thanks, Carissa. I'm sure there's going to be ample questions. We're so happy to have you on. Great. So I'm going to start with a few questions and then turn it over to Dr. Thornton here. Let me see. Nestor, I had a question for you related to just your great article about the monoclonal antibody with the Lilly. Can you compare that to the clinical trials that were done by the Regeneron monoclonal antibody? Is it about similar efficacy so far, or does Regeneron seem to be slightly more efficacious? Can you remark on that?
Yeah, thank you. Yeah, well, Regeneron has not published its results yet. They have like a sort of a press release that they share with their investors. So the information is somewhat limited, but it seems to be the same data. They especially in patients who do not have antibodies, preformed antibodies, or who have some risk factors, they tend to be protected from hospitalization, and they seem to lower the viral load faster than the placebo. So, because remember, with COVID-19, normally people drop their viral load after 8 days. A lot of the patients are not, having excretions. So it is expected to go down, but it seems to go down faster with this monoclonal, especially if given to patients who have not mounted a response. Apparently, the advantage of giving it, if you give it too late, this probably doesn't make any difference. And in fact, some of these trials have been stopped because they see no advantage in the advanced patients who are already in the hospital with mechanical ventilation. Actually, the Data Safety Monitoring Board of Regeneron actually stopped the study to look at the data more carefully because they saw some type of safety signal. But this is all in lay press. We have to wait for the publication to actually bite on this new information. But I think, yeah, if you ask me, based on what I've seen with Eli Lilly and Regeneron, they're going to be useful early really early, and especially on those patients who do not have their own antibodies. So it have to be given very short after you develop the disease, if it's going to be used with the disease. They're also doing studies on prevention. So people like in nursing homes and other high risk situation as a pre-exposure or post-exposure prophylaxis to decrease the possibility of being infected. But so far we have only seen in mild disease, and it seems to have some advantages early, but we have to wait for the data.
Thanks,
Dr.
Nestor.
Sosa, Leslie Hayes here. How would they choose who to give it to? Since, I mean, what I'm reading is that they'll have 100,000 doses at the end of the month, and we're getting almost that many patients a day at this point. It just seems like, are there any estimates on how they're going to decide who to give it to?
No, honestly, I haven't seen that. And I mean, this is an IV base case scenario. It may be IM, but it's a parenteral therapy. It has to be given really early. I mean, and from the experience that we have gathered in the hospital here, enrolling patients in the remdesivir trial, patients usually develop symptoms and they hang around for like 3 or 4 days before they actually come into the hospital, and then they get tested, and the test result takes obviously a few more hours, maybe up to 1 day. So when you are actually given these drugs, if you decide to give it, it's going to be day 4, day 5, maybe later in the disease. So it's really difficult to implement this parenteral therapy like really early on, because I don't anticipate people having like a $25,000 vial of Regeneron in their medicines at home. So it have to be given really early. You have to make the diagnosis really quickly, and then get the infusion rapidly, like they did with the president. Otherwise, it's probably not going to be that effective. So.
Thank you, Nestor. Wanted to see if Dr. Seibold, if Dr. Harry Seibold might want to unmute and ask his questions about the mini proteins.
Sure. Had to find my mute button. I
Thanks,
was
sir.
interested if Nestor or any of the panelists had a comment. I wasn't sure on your statement about the picoproteins. I had asked a question probably a month and a half ago. I'd seen a press release. Kent looked it up, and all we could find was just the press release from the University of Pittsburgh Medical Center, or University of Pennsylvania Medical Center in Pittsburgh, about an antibody treatment. I think they call it AB8, and it was a small slice of an antibody that they were going to market. And if that was the therapeutic modality that's talked about in the study that you posted today on pico.
Right. No, my understanding is this is sort of a copy of the ACE2 protein. So it has some similarity with the area of the receptor. It's not really an antibody like the nanobody is an antibody. It's a portion of an antibody. So I think it's slightly different. They all looking for the same thing, a protein that attaches to the area where the actual spike protein meets the ACE2 receptor. But for this particular, what they call the mini proteins, were actually just proteins synthesized to perfectly fit in the scaffold in the area of the receptor binding domain of the spike protein. So it's slightly different. The idea at the end is the same. It's preventing the infection of the cell by covering the spike protein. But this is not really an antibody. It's actually derived from the amino acid sequence of that area where the ACE inhibitor attaches to the spike protein.
Thank you, Nestor. Turning it over to Dr. Thornton. Thanks.
And just a question, Nestor, about if you have had COVID recently, when can or should you get the flu shot? And maybe we can ask Leslie what she's telling her patients as well, but go ahead.
To be honest, I haven't thought of that. I guess once they are recovered, they can get the flu shot, but I don't know what Leslie. I would say, I mean, don't get it while you're febrile and having all the symptoms, but as soon as you recover clinically, you're probably good to go. But I haven't read anything. Honestly, it's my opinion. I haven't really read about the timing and COVID. I don't know, Leslie, if you have something with that.
Yeah, I actually looked this up, and there's no contraindication. I mean, the big thing for us is we want them not to be infectious anymore, so we're making them wait the 10 days after diagnosis. And I had somebody get really upset about it, thinking that was ridiculous, but I figured that the risk of infecting clinic staff is not worth, giving the flu shot 5 days early. So.
Right.
Thank you. Heather Brislin, do you mind unmuting yourself and asking your question?
My mouth is full, I'm sorry, yes. So I've had a number of people, maybe 3 different patients ask same question, same scenario, which was, okay, this person we know just tested positive, and so had lunch with them on Wednesday. I saw the intermediate person on Thursday. Am I now at risk? Like a secondary exposure, second degree exposure. And my thought is, that person couldn't pass it on to you within 24 hours of their exposure. The incubation period is too long. The chances that they could get it together to be contagious that quickly is really unlikely. And I was just hoping to hear your thoughts, because I don't want to be overconfident about my understanding.
Right. Yeah, thank you. That's a good question. And we deal with that all the time, that we're doing contact tracing and asking and looking for context. Well, the transmission period really starts 48 hours before the symptoms. So if the person was with a contact earlier than that, it's probably no risk. But sometimes it's hard, because sometimes they are and they haven't been tested. But we usually use the time of the symptom initiation. You go back 48 hours, and that's the infectious period. But we don't usually recommend quarantine or testing for secondhand exposure in that way, because it gets complicated. It really gets complicated. It's only if you were exposed to an index case. But it actually depends on the setting. If it's like a congregate setting, you can be more flexible. You can do more testing, sort of an enhanced surveillance. But really, the mandate is just to quarantine and test those who have been exposed to an index case, if they were exposed 48 hours before and up to 8 days after, in general. So that's the window.
I guess, is there this seems like it would take advanced contact tracing or a crystal ball to be able to say this, but is there any sense of what's the shortest incubation period we're seeing from a period of exposure to communicability? And that just might not be known.
Right. I don't know. I honestly don't know. I know the rule, it's minus 48 hours. So I don't know. And the other difficult thing is patients who are asymptomatic and they get tested because of whatever. And then when were they? It's so hard to establish, because if maybe you were shedding virus for 3 days and then you get tested on day 4. There's some way to tell, because when you're asymptomatic, it's very difficult to establish when you started your viral shedding. We go by the 14-day rule for the quarantine and the 10-day rule after the diagnosis, but we don't really know what happened before that if you were asymptomatic, because there's no way to tell 48 hours before what, before you got the test, probably, but who knows? It's really more difficult in the practical sense.
Thank you.
Thank you, Heather, for asking that complicated question. It is it's so complicated. Let's see, Carissa, Doug Clark was asking, does TriCore have an estimate on the positivity rate for COVID and any projection in the actual rate of virus carriage in New Mexico Northwest?
So right now for our positivity rate, we're seeing anywhere between 6 and 8% positivity, but it's really dependent on the population that's being tested. Of course, we see higher volume, higher positivity rates in certain populations. I don't have any region-specific data in our TriCore data, but I believe that you can go to the New Mexico Department of Health website, and their COVID dashboard has some pretty good projections and regional positivities. We're actually updating our TriCore website over the next several weeks to be able to include more precise information about both COVID and other respiratory viruses and their regional positivity rates. But I don't have that data right now.
Thank you, Carissa. And Marla Sievers, our resident public health expert, couldn't be on today. She sends her apologies. Dan Saltman, do you want to unmute yourself and ask your question about vaccine safety?
Sure, thank you. Thank you everybody for your great information. Let's see, they for the vaccine protocols, they published the criteria, the evaluation criteria, and I think that they were going to evaluate the safety out 8 weeks after the final vaccine. And there was, the White House was kind of pushing back against that, trying to shorten it. I was wondering what the current, that was maybe 2 weeks ago or 3 weeks ago. So I was wondering what the current status of that was and whether it's just remained at 8 weeks. I mean, even 8 weeks seemed short to me. That's sort of an accelerated. So, 8 to 12 weeks, 12 to 16 weeks to see if there's any side effects. And we all know that drugs have been pulled off the market a year after their release or a couple years after their release. So I was wondering about the current status of that safety evaluation.
Yeah. So thank you, Daniel. This is what the latest thing that I heard. The FDA had sort of a town meeting with the companies, with our researchers. Yeah, I think it was a couple of weeks ago, and they actually first. I think that they haven't really published the decision, but the comments during the meeting was that they were gonna keep the 8 weeks at least, and that they, instead of going for an emergency use authorization, they were gonna go for full licensing. So I think that they are considering being more conservative than initially. Well, we thought that they were gonna give the approval in October or early November, and then it was pushed back to December. I think now based on the discussion that I heard from these, analysis was that they were gonna go, for a more slow pace, try to gather more information. They were not going to stop the trials, even if they're able to show some efficacy after the 8 weeks, efficacy and safety. Those patients should continue on trial. And I think the end goal is to get the more complete approval, the so-called full approval, as opposed to just an emergency use authorization, based on the concern of the scientists and everybody who were actually really afraid of a very accelerated approval process. So I think that's the latest. I haven't seen any official thing from any of the companies or the FDA, but that was what was discussed in that meeting, keeping at least the 2 month, 8 weeks to see efficacy and safety, but continue the trials and hopefully go for a more thorough evaluation that includes like inspections of the plants where they manufacture the vaccine and other things that the emergency use authorization seems to bypass. So that's what I know, but this is like secondhand because I listened to part of the FDA meeting, and people have also corresponded with me or sent me emails about that. So that's what I know, but I think we're moving to a more conservative evaluation of the vaccines, especially now that the decision is not going to be made before the election. So I think that's going to give everybody sort of a breathing space.
Thank you, Nestor. Carissa, there's a question about I think it's just about the volume of testing that you're doing at TriCore. Can you just give us an idea about the volume that you're seeing right now?
We're getting anywhere between 2,000 and 3,500 or so tests per day. And we continue to operate 24/7 on multiple platforms to try to get those results out as quickly as possible.
Thank you very much. And
I have a question, a follow-up question for Carissa, Carla.
Yeah.
You're still doing mainly PCR, right, Carissa? You're not doing like mass antigen testing, or it's mainly PCR in different platforms. Is that correct?
That's correct. PCR on multiple platforms. Manufacturers are in various stages of submitting to the FDA for an emergency use authorization for antigen-based testing on some of the larger platforms. But we really don't have any data right now on the sensitivity or performance of those kind of big box, the same type of platform that would run like a hepatitis B surface antigen, right, type of test that just goes out in a higher throughput. Those are not yet approved by the FDA. And so we're waiting to understand more about those performance and how they could be used.
Thank you. Harry Seibold, would you like to answer, would you like to ask your question that you put into the chat?
Sure, I'll see if I can put it in a form that's intelligible for any one of the panelists there. There's been some discussion about tactics for, especially nursing homes and other types of congregate settings, for how to keep them safe. And as the prices of some of these antigen tests come down dramatically, some people have suggested frequent testing with a lower sensitivity test may actually bring up the effectiveness of that, such that it's equal to using a PCR test 1 or 2 times in that congregate setting in terms of keeping the entire population safe. And I've tried to wrap my heads around the statistics of that, and I haven't quite been able to do that. And I was wondering what any of you thought about that.
So I think it's an interesting approach, and it truly is just a basic probability issue. If even within the best case scenario, it looks like these antigen tests are anywhere between 75 and 85% sensitive when used in the right patient population. So it's, you've put into a bag 4 different things and see how often you pull out the right answer. I mean, it truly is a probability. So if you have 85% chance of getting the answer correct one time, you can improve your probability either by increasing the sensitivity of the test or performing that same test multiple times. And so that's truly just the statistics around it. But I think that the challenge is that the sensitivity that I just described is within the patient population as described by the package insert for those tests, which is patients within anywhere between 5 and 10 days of symptom onset, depending on the test. That does not take into sensitivity related to asymptomatic individuals. And so I think the concern within those asymptomatic individuals is that the sensitivity drops dramatically from 75 to 85% into, as low, some studies have shown sensitivities in the 20s. And I don't know that you can test at a frequency high enough to be able to overcome a sensitivity that's below 50%. So I think that's one of the challenges. And then of course, within asymptomatic populations, you also run into the challenge of false positives. And so there's algorithms for how to address follow-up testing in these patients. If you have a patient with symptoms and high likelihood, maybe you repeat the negatives. If you're testing asymptomatic patients, perhaps that's a population in which you would retest the positives with a PCR test to be able to confirm. So that would really be the strategy, but it takes a lot of coordination between organizations to find a strategy that will work.
Great, thank you so much. Nestor or Leslie, did you have any other comments about that?
No, thank you. That was amazing.
Great, thank you. I just want to ask one question that was sent in prior to the session about how long can COVID live on surfaces? I know, Nestor, you talked about this a couple of weeks ago, but I don't know if you could just give a little summary.
Yeah, well, in the latest paper was about the skin. It lasts for at least 8 to 9 hours. They were able to show in this Japanese experiment that it lasted for that time, 8 to 9 hours. In the surface, depends on the surface. There are, materials like stainless steel and glass that it can last for days. We are talking several days. I've seen 4 or 5 days in some of the series, and even longer in a few isolated reports in which they have been able to find the virus, a couple of weeks after the original contamination, presumably. And in porous materials like paper and cloth, the duration is less. So we're talking about maybe 1 day, 24 hour around that. So there's that margin from hours in over human skin to all the way to several days. Maybe up to a week in very inert materials like stainless steels or glass. That's sort of a short review. I think the bottom line is wash your hands, even if it's not the main transmission mode. If you're around patients or potential patients that may be contaminated areas, I think it's important to maintain the hygiene and wash your hands.
Thank you very much, Nestor. I just wanted to let everybody know that the CME link went into the chat a couple of minutes ago, so please fill that out if you would need CME, and also we'd love to hear your feedback. And I'm just going to turn it back over to Joanna.
Thanks, Carla. Thanks for all these great questions from everybody. Just wanted to go back up to Dr. Kohlmeier's question about any pre-COVID clinics or post-COVID clinics or patients who may be positive with COVID-19 or definitely are. Dr. Kohlmeier, do you want to unmute and ask your question? And I think Dr. Baer might be able to kind of respond just so we can, there's some
Sure.
chatting going
Yeah,
on.
I'd love to, and thank you, Dr. Baer, for telling me about your clinic. I mean, I've had several patients that are just so sick and home alone with maybe somebody helping them, and I just feel helpless if I can't send them somewhere short of the ER urgent care for, you know, a spinal tap or just to someone listen to their lungs. So I'd really love to establish the COVID-like clinics that you have in New Mexico here in Washington, specifically in Spokane.
Thanks, Dr. Kohlmeier. Dr. Baer, do you want to maybe just tell everybody a little bit about what you and Dr. Parada are doing? I know you guys came onto the Critical Care Echo a couple of months ago, but just very briefly.
Sure. So I'm Deborah Baer. I'm a family NP. I'm not a physician. Actually, Dr. Parada identified this need, and I kind of jumped on board right away that we knew people were getting tested, being discharged from the hospital, and being told to go see their primary. And we were both working in primary care clinics and decided that seems like a horrible idea. So we just put this together. So we start with virtual visits most of the time, and we bring people in who need a face-to-face vital signs, especially for hypoxia, but also we've had prenatal care that was needed. We've done newborn visits more than we ever expected because of asymptomatic testing during labor and delivery and people not really wanting to see a new mom and a new baby. And we've had a variety of ages, and it's been a really interesting experience to be talking with people, literally from the medevac folks from the Navajo Nation to our local folks. So we've had a variety of patients over these last 6.5 months.
Thanks so much, Deborah. Might I ask you, do you have patients who you've had that you're seeing kind of post-COVID that have had to kind of be re-hospitalized, or it seems like you have an amazing continuity of care? Can you talk about that?
We have had a couple that have had to be rehospitalized. There was one, so we're also participating with the UNM on some of the research patients. There was one with lymphoma that I actually tested at ED Annex myself, and she's still in the hospital. I think she's on her 5th week in the hospital, but I mean, there's things you can't prevent. So we do our best to try to manage people outpatient, because it does seem that oxygen support is really crucial, and just having someone to talk with and try to troubleshoot some things to help them through this really helps most people. So.
Thanks, Deborah. I'm just going to deviate a little bit and just ask anybody who's might be a clinician working in kind of the Navajo Nation if you might be able to tell us what's happening in McKinley County or in the Navajo Nation right now, if there's what's happening in terms of COVID and with their clinics, or if they might want to chat in that they can speak to that. In the meantime, another question came in that I wanted to ask Nestor from Dr. McCreath. Is it true that temperature is no longer a determinant factor for COVID-19? I guess there was some thought that when the summer came, this was back in March and April, when the summer came, that things would go away. And I guess we're definitely not seeing that, or the winter for that matter.
Right. Yeah, I think the fact that there were so many cases in different places of the world at the same time, and I can speak for the tropics in Latin America, where the temperature, it's like always 90 degrees. And they had huge, Peru, it's like the case with more mortality in the world. Brazil had a huge epidemic in different latitudes because Brazil is such a large country. So I think, I think the conclusion, although I haven't seen anything like a pronouncement, I think there's no such a clear-cut relationship between temperature, weather, and the virus in general from the epidemiological standpoint. Although we know that during the winter time, people congregate indoors, they close their windows. So there's also sort of a human factor, human behavior factor, more than the temperature itself. It's actually the fact that we are going to congregate during the winter, and that increases the risk of respiratory infections. And that has been the same for influenza, RSV, and other respiratory viruses. It's like a cyclical thing that not necessarily, in the case of COVID, may be related to a strict relationship between ambient temperature, but it's the human factor, I think.
Thank you, Nestor. And do we have an update on if influenza rates are steady or perhaps down right now because of mask wearing in certain areas? Carissa.
Yes, so right now we are seeing, it's pretty early for flu season. We don't usually start to see flu rates increase until into December and early January. But when we look year over year, the numbers are low, and we're seeing that across the country. So we're hoping that between mask wearing and the vaccination rates that were discussed earlier, that we'll be able to keep our numbers low. When we look at other respiratory viruses, though, we normally would be seeing higher levels of rhinoviruses and the common coronaviruses, and we are not seeing those numbers. So I'm cautiously optimistic that our overall respiratory virus season will be lower with all of the masking and social distancing and hand washing that many of us are observing.
Thank you so much, Carissa. Let's keep our fingers crossed on that. Right. Jonas Pelage asked a question, and I think some of it has been answered by you, Carissa. But in terms of I know predominantly you're doing PCR testing, but in terms of it, has there been any update in terms of the sensitivity and specificity of any of the tests that you're using right now?
So, I think the majority of the PCR tests that are being used all have very good sensitivity and specificity. We're not seeing some of the challenges of specificity that's been observed with some of the rapid tests, like the Abbott ID Now has had some challenges with specificity when used in the wrong patient population. And of course, the antigen test has the issues with sensitivity that's been described before. So right now, the method of choice for diagnostics in the largest range of patients is the PCR. And I think we're all feeling fairly confident with that. I think there can be questions about later in disease for monitoring the use of the PCR, but right now for diagnosis, the method of choice and the gold standard is PCR.
Thank you, Carissa. And I just wanted to let everybody know that in terms of some clinicians from the Gallup and Navajo area, Maria Bruckner responded. Thank you, Maria, Dr. Bruckner, that she's a cardiologist. She's that they had recently scaled up their elective work, but they're in a readiness mode to postpone all of those changes as they anticipate an acceleration of cases. And then Dr. Gonzaga from internal medicine. Well, Dr. Gonzaga, do you want to unmute and let us know what's going on in your clinic, if you're able?
Hi, thanks for having me. Do you hear me?
Yes, we can hear you a little better now. Yes.
Yeah, so we're doing, 50% face-to-face and 50% telehealth. And we're still getting a lot of cases. In fact, over the weekend or over the week, we have 10 new cases in the hospital that have to approve for remdesivir rolling up. Some of them are coming from the nearby IHS that had been in full capacity. But we're planning overall to have an outpatient for COVID just for follow-up with the rest of the other providers who are interested to follow through with these cases that we have. So, but thank you for Nestor and everyone else, for Carla and Dr. Katzman for having this week by week. I enjoy the interactions, and thank you for all the inputs, even from the Department of Health and every other people that we've learned from each other. Thank you.
Thank you. Nestor, do you want to comment or talk to Dr. Gonzaga about anything?
No, no, my pleasure. I saw part of the question. There's Maria put at the end of his question about the overlap of Native American, Navajo, and Neanderthal. I don't really know. I'm going to look it up and see if there's any significant gene inflow. From the paper that I reviewed, the Americas were not, it was not very frequent, but that was sort of a mixed population in the Americas. They didn't specify Native Americans or any specific ethnic group. It was just Americas, Europe, Asia, and interestingly enough, in the Orient, in China, there's not too much of these Neanderthal piece. I mean, but this haplotype that is not present there. But I don't know in Native American. I will have to look it up to see if there's any significant presence of that 50 kilobase haplotype in our native population.
Thank you so much, Nestor. I'm just looking at some of the, actually, I'm looking at the time is what I'm doing, and it's the top of the hour. This hour went so fast, and I wanted to wish everyone a good week and to stay safe tomorrow and the rest of the week, and for keep using your physical distancing and masks and your hand washing. And we look forward to seeing you all next week, and keep on bringing the pre-registration questions and all your participation. We greatly appreciate. And we're so grateful to Dr. Sosa and to Dr. Hayes and to Dr. Culbreth and Marla Sievers and all of you especially. So thank you and be well.